Hi guys, welcome to another electronic clinic video tutorial. Today's tutorial is about designing our own circuits for the PLC rather than purchasing expensive modules. These circuits can be easily manufactured at home. This tutorial is very important and I suggest you watch this tutorial from start to the very end if you are interested in designing, because the circuits we will be designing today will be used in upcoming tutorials. So this tutorial will cover the hardware basics. We will be using the same circuits in the future projects. The upcoming tutorials will be on product size based counting, visitor counting system, bidirectional without any errors. Well, there are so many other visitor counting systems available on YouTube, but those systems are not accurate. And I will also be making tutorials on manual counting, automatic book fetching and placing robot, automatic two-way switch, water level monitoring, remote control based PLC control system, and so on. So we'll be doing hundreds of projects. Now let's get back to our topic on hardware designing for the PLC. Today we'll be designing a switch module and an Hbridge module. As you know, in industries there are a lot of buttons used for different operations. So we will be using the switch module for the manual operations. Hbridge is used for the DC motor direction control, which is very useful in robotics and can be used for linear motors. I will also make tutorials on how to use the linear motors and how to control them using PLC. And we will also be using the linear motor for box shifting from one conveyor belt to another. For the schematics and PCB designing, we will be using cadeSoft Eagle software. So let's start the designing. So now let's start with the switch module. Open the cadeSoft Eagle software. I'm using 6.3 version, which is easily available on internet. So click File, New, and click on the schematics. Now first of all, click on the grid and on. Okay, now we did some parts, so click on the add and right here 40-XX, which is a push button. We will need 8 buttons, so 1, 2, 3, 4, 5, 6, 7, 8. We will also need connectors, so AK 300/9. Okay, now let's start the wiring. Now this is a push button, so these two pins are connected, internally connected, and these two pins are connected. So click on the net. Okay, now let's connect all these. Okay, Okay. Okay. Now let's start connecting these. This is switch number 1. Connect this with number 1. This is number 2. This is number 3. Four, fifth, six, seven, and 8. So the PLC ground will be connected here. So click on the net and connect this. This one. So now click on the board to make a PCB. Start with switch number 1. Switch number 2. Three, 4, 5, 6, 7, 8. Okay, now click on the tools and click DRC. Click on the sizes, and here you can specify the width. So let's keep it 40. This is for the automatic routing apply. And now if you click on the auto, so over here make top NA and make bottom star, so it will do the routing only in the bottom layer. So as you can see, so now it's ready. If you want double side PCB, simply click Ctrl Z, click on the auto and make this star and also this one. So now it will make a double side PCB, as you can see. So this is the automatic routing. And if you want to do the manual routing, well, I personally do manual routing, because during the manual routing you can change the line widths. While in this design you can see the lines are of the same width, while in the manual routing you can change the sizes during the designing. So let's do that. Press Ctrl Z and now click on this, which is route, and now from here you can select the width. For example, I want to keep it 0.05. Now manual routing takes time, but it's good. I like it because you can change the sizes. For example, I want to increase the width, so just click this one. You can also change the type by clicking the mouse right key. You can change the size, the style. First, let's reduce the size. Group and move. Okay, now click on tools, DRC, and let's change the size to 60. Let's keep it 70. Apply, check. Now click on the tools, and this time I want to make two-side PCB. So click on the auto, star, and click OK. So now this is our final PCB. Let's make it a bit stylish, so click on polygon. The isolate is 0.032 selected and spacing is 0.05, and now let's make a polygon while the bottom layer is selected. So click, and now click over here and click on the redness. So you can see it looks pretty cool now. Let's also apply the redness on the top layer. So select the polygon, and now this time select the top layer. And now press redness. So this is the double side PCB. You can check the individual layers. Apply. You can also hide the bottom layer. You can see now you can see only the top layer. So as you can see, the PCB design is completed, and one side of all the push buttons is connected with this point, and this point will be connected with the PLC ground, and the other sides of the push buttons are connected with these pins, and these pins can be then connected with PLC inputs. So now let's start designing Hbridge. So again, open Eagle 6.3, click on new, schematic, click on create, display on, and click OK. Click on the add. We will be needing a relay, so write a relay and search for the relay. So this is the one I'm going to use. So select this one. Okay, I will also need connectors, so write AK 300-2. Okay, click on the net, connect the common pin of the relay with one pin. This one, check it's connected or not. Yeah, it's connected. Okay, so now let's make this one ground and this one 12 volts, and this is going to be the external supply. So net connect this with the normally close, and this one with the normally open, and also for this one connect 12 volts with the normally close with normally open. And also over here let's make this ground and this one 12 volts. Click on copy, and we need another one. And let's connect this 12 volts here, and the ground to the relay coil, and also from here to another relay. We also need another one. This will be used for to PLC. Outputs. So click on the nets. Okay, now this is the ground. Okay. So again, now how this system works, it's easy actually. These over here, the motor will be connected. So these two pins are for the motor. The 12 volt is connected with the normally close of both the relays, and the ground is connected with the normally open of the relays. So let's, for example, we turn on this relay as the ground is already connected. So when we turn on this relay, this contact with short with this one. So as this is connected with the ground, so the ground will come from here, and as the 12 volt is connected, as the 12 volt is coming from here through this, so the motor will be rotating in one direction. If we turn this off, it will go back to its previous position, and we turn this on, so this side will become ground, and this one will be 12 volts, so the motor will be rotating then in another direction. So let's start making the PCB. And as this connector is connected with the common, so this is for the motor. So this is the external supply.
Switch back. And X5 is for the PLC outputs. So let's connect this one over here, and X4 is for X4. This will be used for the PLC common. So let's write. This is the supply. This supply is only used to turn on and off the relays, and this is the external supply. And this external supply is for the motor, and this one is the motor. And this one is for the PLC outputs. So now let's rearrange the components and try to reduce the size. We still have a lot of space. It can be further reduced if we shift. We can bring this one on this side. And now let's start the routing. So click on the DRC, click on the sizes. Let's keep it 80, apply, check. And let's make it only in bottom, so click out and star. No, keep this as NA, and this one star, and click OK. Okay, now this is ready. Now let's apply the polygon, keep it 0.308 and click, select the bottom. And click on the redness. We can also write names on PCBs, so how? Let's write electronic clinic. You can change the size here, and now just simply go and click the redness to update, as you can see. So that's it.
That's how easily we can design our own PCBs, and then these PCBs can be used with the PLC or microcontrollers to control DC motors. If you like my video, subscribe to my channel, share my videos with your friends, and thanks for watching.